Scientific notation used with numbers far from 0.
He scratched that out.
Yeah, got rid of the really. So used with numbers far from 0, and that's 2.8, today's stuff. And close to 0. Maybe I should have put in the numbers that are really far from 0 and really close to 0, so that's 2.9. So we're talking, usually you see scientific notation with numbers that are like in the millions or billions or trillions, or like 0.000000001. So it's going to be numbers that are really close to 0 or far from 0. So today, section 8, we're just doing numbers that are far from 0. So really high, really big positive numbers, or really negative numbers far from 0. Okay. They're helpful in numbers with lots of zeros. And then number 3, the format, it's always written as a number and then a decimal point. So usually a single number, decimal point, then maybe more numbers times 10 to some number. And what I'm really trying to get at is down here, if you look at below your Roman numeral 3, I'll go back. But this here is a number scientific notation. You have one number, decimal point, then maybe some other numbers, times 10 to some power. So that's what I mean by scientific notation. And the E key on your calculator, well, the screen will say E. The key on most of them look like this here, at EE. That's a lot of the Texas Instruments ones. But I'm seeing some calculators that say like times 10 to the X. I've seen some older ones, especially some older Casios, that say EXP. So you'll have a button that says something like that. But that button there, and we'll come back to the calculators in a minute, so maybe get your focus back up here. We'll do calculators soon enough. But the E key on the calculator says this here. It says times 10 and then the little exponent thing. So it says, technically it says parentheses. It tells you it's all one number. And then times 10. Then I'm going to do the little up caret to show like the exponent. So all of that stuff in blue there, when your screen just has an E on it, or maybe has the two little numbers in the upper right, means times 10 to some power. I'm going to do these in a little bit different order. So I'm going to jump down to my Roman numeral 3. Before I get there, I don't know if I'd write this, but can I convince you times 10 squared? That's the same as times 100, right? Can I convince you of that? Now, if I were to have a number like 2 times 10 squared, do you agree that's the same as 2 times 100? Which is going to be 200. So I wouldn't write this stuff in blue, but does that logically make sense, people? I'm going to make it one step kind of uglier and say, all right, what if I had a 2.4 times 10 squared? That's the same as 2.4 times 100, yes? Which would be 240. Does that seem to kind of logically make sense? So what scientific notation is really doing, because scientific notation, this here is the scientific notation. And times 10 squared, that's the same as times 100. But do you agree, when I started here with my 2.4, how many places did I move the decimal point in each of these situations when I multiply by 10 squared? I moved it 2. Because 10 squared is just a 1 with 2 zeros, so we move it 2 decimal places. If instead this were to be a 10 to the 4th, how many decimal places would I have to move it? 4. So as we do these problems here, it's really just the 5 in this first one is really just saying I move the decimal point 5 places. Now the most common mistake is people will do this. I wouldn't write this down, but they'll do 3, 2, 7. Oh, 5 places. 1, 2, 3, 4, 5. They put 5 zeros after it. How many zeros do I need to have? Not 5, but 3. Because you agree I moved my decimal point 3 places? And it starts here, the 3.27. How many jumps does it take me to get to the end of my numbers? Well, maybe, do you agree it takes me 2 here to get to the end? Well, I have 5 jumps total. I just used up 2 of them. Do you agree I have 3 more to go? So the final answer then would be, I can't erase them anymore, but final answer would be 327 million. So I'm sorry, 327,000. Okay. So So I would write that down now. That's actually the right answer. And what we did is we took our decimal point from here. So our decimal point was there. And we moved it 5 jumps. 1, 2, 3, 4, 5. I probably wouldn't write in the purple. But does that logically make sense to people? Yes. The next one, don't let the negative mess you up. If we're here, how many jumps do we have to do on this thing? 8. Takes me how many jumps to get to the end of my number? 3. So how many zeros do we add after that?
4.
5. Because we use up 3 of the 8. 8 minus 3 is 5. So we just copy down that number that we had before. Negative 4, 8, 1, 7. So we know it took me 3 jumps to get to the end of the 7. I have 5 more jumps to go. So I put in 5 zeros as placeholders. Technically, the decimal point is right there in the end, but usually we don't write it because it's not simplified. You don't need it there. But I was always taught commas. Just if you have 5 or more digits, put in commas, starting 3 away from the decimal point. So then it's easier to see that it's negative 481,700,000, and so on. Pretend that didn't happen. All right, should I do a couple more, or are you guys feeling good?
We're good.
Good. Or maybe I'll light years. So if we have this one here, I need to go how many decimal places on this guy? 12. Takes me how many to get to the end of my number?
2.
How many zeros? 10. So I have 5, 8, 8. That uses up 2 of my 12 jumps, and I need 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can put in your commas, starting there at the end. Wow, so that'd be, what, 5,880,000,000,000?
Yeah.
Don't know if it's miles or kilometers, but it's big. Actually, I should do this last one. This last one, I move it how many jumps on this guy? 2. So my final answer is?
382.91.
Nice. Because sometimes my 2 jumps doesn't get me to the end of the number. It just gets me there. So I have 382.91. We okay on those? If we jump up to Roman numeral 2, we're really doing that same thing backwards. So we always do one number than the decimal point, so it would be 4.5 times 10. And we just have to say, well, my decimal point started here at the end of the number. I want to take and put it right there. How many jumps is that?
7.
6. You could, if you don't want to count every one, up to every comma is going to be 3, right? So for the big ones, I do like 3, 6, then maybe a 7 or 8 or something, but times 10 to the 6. 4.5 times 10 to the 6. Next one, what do I have before my times 10?
Oh.
Almost perfect with 3.24. What do we need to add? Negative, yep. So you have to include the negative. So negative 3.24. So we're putting our decimal point right there. It was at the end. So we then say negative 3.24 times 10 to the?
Third.
Not third, because third would get us to here. Something, okay.
Yeah.
So 3 would get us to here, 1, 2, 3, but we have to go 4, 5. Yep, so times 10 to the 5th. 52 million, some people look at that in their head and just do it. You might find it's a lot easier to say 52 million is 52, comma, and then throw 6 zeros after it. And then if you do that, it might be easier to say 5 times 10. 3, 6, and then 1 more gives me 7. Yep, good call. So 5.2 times 10 to the 7. My last one, decimal point starting there. We want to put it right there. So 6.54321
Oh, very funny.
times 10 to the 3, 6, 9. Yep, I like the 11. Good. So we have 3 to get there, 6, 9, and then 2 more, 10, 11. So. How are we doing? Good. Very last thing, practice punching them in the calculator. For those, this one here, technically, you could go start to finish and be okay because your calculator degree, it's set to do exponents first. So if you punch all that in, it's going to do the 10 to the 8th and the 10 to the 7th first. And then after exponents, it's going to do the multiplication. And then last but not least, it's going to subtract them. Agreed? So this one here, you actually can get away with not really knowing a whole lot what you're doing. If it's a division one, though, it matters. Because division, you have to force it to look at it as, oh, this is all one number, this is all one number. So I would look at it this way. We talked about that EE button or EXP button or times 10 to the X button. That those buttons there, they tell it it's parentheses. They tell it, okay, this here is all one number. And they have like the times 10 to the X to the power times 10 to the power. So if you want to type this in, this could be your key sequence. You could do 5.24, and then you have one of those buttons, EE or EXP or times 10 to the X. And then all you have to do is do the 8. I had a bunch of people last hour that they did EE and then they did the exponent key. It already did the exponent key. So that right there is my first number. Your calculator sees this and says, oh, 5.24 times 10 to the 8th. And then minus 9.81. Then that EE button. And again, just one single E will show up on the screen, or you'll have the exponent and small numbers on the right. 7. And then you can hit equals. And you get a big number.
425 million.
I got a domain there.
Yeah, that's what I got.
Yeah.
So, yep. So you should, if you punch everything in right.
Is your fault
Yeah.
all the E buttons?
So if you struggled with that,
Yes.
I'll help you in just a minute. Other people, if you got it, great. Go start doing the homework. So.